We've learned a lot so far about cutting-edge simulation techniques and relevant software such as Blender and TetGen. Here's a summary of our progress so far.
The reference paper we are using is from Jeffrey Smith, and in their paper and our simulation, we are going to replace springs between point masses with distance-preserving constraints. And the mesh of our brittle object is represented by a set of connected tetrahedra, and the point masses are the center of those tetrahedra. And the mesh generator we are using is TetGen. Here is an example of the sphere tetrahedralized by TetGen.
We move our object's fractures into Blender by using the knife tool, and from there we can simulate an object such as a ball coming towards the contact point, hitting the contact point, and generating the impulse necessary to create the fractures. Currently this is implemented using the default cell fracture option in Blender, which will serve as a nice baseline for our method.
We attempt to find where the object's constraints break given impulse. Our algorithm takes in a force, and we solve a linear system to find the equilibrium forces and then break the constraints if the force exerted in response exceeds the limits. We actually break our impulse into a schedule of forces. For example, 10 force distributions according to this schedule. We want to load forces slowly because it doesn't actually make sense if we have broken constraints that are exerting more force than they should be during equilibrium.